Okay, now on today's assignment we're going to look at a different type of factoring. 4x to the second minus 9. There are two terms here. There's no GCF. But what we do have is what's called a DOPS. Now that stands for something. Difference of perfect squares. Difference of perfect squares. Okay. Here's the list of perfect squares on this sheet. 1's a perfect square because it's 1 times 1, so square, we don't really use 1 at all. 4 is 2 times 2, square root of 4 is 2. 3 times 3, square root of 9 is 3, so forth, so on down the line. Okay, now what we're going to do here is factor the following expressions. Okay. First we need to look for a GCF. Some of these actually have them, some of them don't. Okay. And then I got two kind of steps here. Okay, first is a GCF if I can find one, then the next is to factor it with the difference of perfect squares. Okay, GCF. The number, I don't have a negative in front, I don't have an X on both terms, and then I have 1 and 25. So if 1's the smallest, there's no GCF. So we can go ahead and forget about that. Now, what we need to do is check for a difference of perfect squares. Now here's how you check for that. You need to have a minus in the middle. I have that. That's good. If I have a plus right away, it's done. X to the second's a perfect square because that's x times x. 25 is a perfect square because that's 5 times 5. So what I do is I go plus and minus, and what I do is I go x, and then 5, 5. So x plus 5 times x minus 5. Okay, next. First I look for a GCF, and then I look for a DOPS, because all these are two terms. Okay, so GCF, first I do have a negative in front. I don't have x on everything. And then I look at 4, factors of 4. We got 1 and 4, and then 2 and 2. So let's see if we can divide the 100 by 4. 100 is divisible by 4. It's 25. Okay, so negative 4. But not x, just negative 4. Now I'd like to see you please underline and put negative 4 so you don't mess up signs. So that's going to be 1x to the second. You can just put x to the second if it's 1. And then negative 25, so put minus 25. Now look in that parentheses. Do you have a difference of perfect squares? Yes, you do. You got the difference, x times x, and 5 times 5. So that's x plus 5 and x minus 5. That negative 4 comes down here. Okay, you just bring it in the front. 9x to the second minus 4. First check for a GCF. I do not have a negative. I do not have x on everything. Now let's check our smaller coefficient, the 4, 1, 4, 2, 2. And I am not going to be able to divide these both by 4 or 2. They'll get decimals, so, and we don't ever use 1 unless I have a negative already. So there's no GCF, so I cross that out. DOPS. Okay, I have the difference. 9x squared would be a perfect square because it's 3x times 3x, and 4 is 2 times 2. Okay, so 3x plus 2 and 3x minus 2. There was no GCF. Okay, the next GCF step, and then the difference of perfect squares. Okay. So GCF, we don't have a negative in front. We don't have x on everything. So now let's think of factors of 16. 1 16 2 and 8. 3 is a decimal, and then we get twins. So when I get twins, the list is complete. Now let's see if 144 will divide by 16. Okay, it does. So I have a GCF here of 16. So I pull the 16 out, divide by 16. So that's going to give you 9x to the second minus 1. Now 9x to the second is a perfect square because that's 3x times 3x. 9 is a perfect square, so is x to the second, and then 1 is 1 times 1. So 3x and 3x, and then 1 and 1, and then I have a 16 out here. 16 times 3x plus 1 times 3x minus 1. Okay, my next problem, GCF. That's the first thing we got to look for. And then we're going to see if we have adopts. This is how you factor two terms. This is how you should be starting to factor it. Okay, GCF, do I have a negative in the front? No, I do not. Do I have x on every term? No, I do not. So 36, 136, 2 and 18. My camera's down.